This kind of ends the instructional portion of this short lecture. However, if you're already skilled in programming the EATON Easy 512 DCR Intelligent Relay, one could perform a quick functions test of the as-assembled trainer. A recommended test procedure is a simple 4-rung program where each input has been instantiated as a make instruction controlling one input. I1 to Q1, I2 to Q2, I3 to Q3, and I4 to Q4. When we power up, program, and place the EATON Easy 512 DCR Intelligent Relay in run mode, note the status display indicates input 2 is energized in the deactivated state and output Q2 is asserted. This is to be expected since the electromechanical nature of the input device assigned to input 2 is normally closed, whereas all others are normally open. When only the normally open selector switch connected to input 1 is actuated, the status display shows that input 1 and 2 are energized and outputs Q1 and Q2 are asserted, as can be expected. When only the normally closed red push button connected to input 2 is actuated, the status display shows that all inputs are de-energized and all outputs are de-energized, as can be expected. When only the normally open green push button connected to input 3 is actuated, the status display shows inputs 2 and 3 are energized, as can be expected, and outputs Q2 and Q3 are asserted, as can be expected. Finally, when only the normally open yellow push button connected to input 4 is actuated, the status display shows that inputs 2 and 4 are energized, and outputs Q2 and Q4 are asserted, as can be expected. Here's the same sequence monitoring the operational program. Note when all switches are in the deactivated state, the make instruction examining input 2 allows logical continuity to Q2, since the electromechanical deactivated state of the device attached to input 2 is normally closed, whereas all other devices are normally open. When only the normally open selector switch connected to input 1 is actuated, the operational program shows logical continuity exists for outputs Q1 and Q2 with a highlighted bold rung. When only the normally closed push button connected to input 2 is actuated, the operational program shows that no outputs are energized. When only the normally open green push button connected to input 3 is actuated, the operational program shows inputs 2 and 3 are allowing logical continuity onto outputs Q2 and Q3 with a highlighted bold rung. Finally, when only the normally open yellow push button connected to input 4 is actuated, the operational program is showing that inputs 2 and 4 are allowing logical continuity onto outputs Q2 and Q4 with a highlighted bold rung. Here's the same sequence zoomed out so one can see the actuation state of the input devices and output pilot lamps. Note when all switches are in the deactivated state, the pilot lamp attached to output Q2 is on. When only the normally open selector switch connected to input 1 is actuated, the first and second pilot lamp are illuminated. When only the normally closed red push button connected to input 2 is actuated, all pilot lamps are off. When only the normally open green push button connected to input 3 is actuated, the second and third pilot lamps are on. Finally, when only the normally open yellow push button connected to input 4 is actuated, the second and fourth pilot lamps are on. If any input or output fails to perform as expected using this simple test procedure and program, lock out and tag out the system and get to work troubleshooting the source of your problems. Most likely it's a disconnected wire or the presence of your lazy lab partner. Alright, that's about it for this short lecture. We'll be making use of this inexpensive PLC trainer in later applications exercises. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your lazy lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.